Okay, so we left off finishing the practice 1 problems, and let's just go through another set for practice 2 here. So practice 2 starts off, and I sent the class the re-edited version of this, so I hope it makes more sense with these questions provided. So magnesium is just an element, so we can just write Mg, reacts with hydrochloric acid. Now I'm trying to get us to remember some of our old stuff here. Just hydroblinkic acid means it's a binary, and the acid just means it starts with hydrogen and then has that little root of the word in there as our anion. So we have HCl here. Since H is a +1 and chlorine is a -1, hydrochloric acid is just HCl. Now predict the products. I said for the most part, when we're not dealing with carbon, hydrogen, and oxygen, which makes CO2 and water, we're going to be looking at charges. Now the charge of a magnesium ion is a +2. Hydrogen is in the group with the alkali metals. I'd say that's a +1. And chlorine is in the halogens. It's a -1. So what we have not done so far is we have never taken two positive ions and put them together. Let's not start today. I think that means that the magnesium is going to react with the chlorine and get MgCl over here, magnesium chloride. But since the charge of the magnesium is a +2 and the charge of the chlorine is a -1, the formula for magnesium chloride would be MgCl2. Okay, now what gets kicked out of the little party here? I guess the hydrogen must be kicked out of this new compound, and we get hydrogen on its own here. Except that hydrogen was one of those Hunkelbrief elements. Remember, hydrogen, oxygen, nitrogen, chlorine, bromine, iodine, and fluorine, Hunkelbrief. That they don't want to be on their own in nature, so it would be a diatomic element, so it's going to be H2. H2. Okay, now I think I predicted my products. Remembering that the subscripts don't have to carry over, we're more focused on balancing charges. Now that I have my products predicted, now I should balance the equation. 1 magnesium, that's good. 1 hydrogen, 2 hydrogens, let's add a 2 here. We now have 2 chlorines and 2 chlorines. Now it looks like we're good. Okay, now question 2b, if a 25-gram piece of magnesium reacts with 25 grams of hydrochloric acid, how much hydrogen gas could be made? So now I know this is a limiting reactant problem because I have an amount of one reactant here and I have an amount of a second reactant here. Whenever we have amounts of more than one reactant, we're going to follow this process. So the first thing we're going to do here, let's turn the amounts of each reactant into product. And it said for how much hydrogen, let's just go to grams here. So I have 25 grams of magnesium. Let's predict how many grams of hydrogen gas could be produced just from the magnesium. So we look at our periodic table, and magnesium was 24.31 grams per mole. We then look at our balanced equation for the balanced equation ratios, and it suggests that for every 1 mole of magnesium, we're going to produce 1 mole of hydrogen gas. And then lastly, let's wrap up this grams to grams problem by using the molar mass of the unknown substance, the hydrogen. 1 mole of hydrogen is 2.02 grams of hydrogen. Now we take 25, we divide it by 2.4.31, we multiply by 1, divide by 1, we multiply by 2.02, and we get 2.08 grams of hydrogen if we're going to have 3 sig figs in there. So now this is how much hydrogen could be made with 25 grams of magnesium. But now let's see how much hydrogen could be made with 25 grams of hydrochloric acid. So chlorine is 35.45 grams per mole, hydrogen is 1.01, so 36.46 grams of HCl are in 1 mole of HCl. We then look at our balanced equation ratios, and I think it suggests that for every 2 moles of hydrochloric acid, we produce 1 mole of hydrogen gas. And then we already did it before, 1 mole of hydrogen gas is 2.02 grams of hydrogen gas. So for this problem, we're going to take 25. We're going to divide it by 36.46. We're going to multiply by 1. divide by 2, multiply by 2.02, and we get 0.693 grams of hydrogen gas. So remember that first question was saying how much hydrogen gas, and I just decided to go to grams. You could have gone to moles here, could be made. So how much could be made is just that lesser value. You can just circle that. We're done. We already did all the work for it. So we can make 0.693 grams of hydrogen gas using these two values, these two reactants. What are the limiting and excess reactants? The product, the reactant that led to the lesser value is the limiting. The reactant that led to the greater value is the excess. Now the HCl led to the lesser value, so I would say that's your limiting reactant. And the magnesium led to the greater value, so that is your excess reactant. So I guess my limiting is my HCl, and my excess is my Mg. Now, we're not always asked this, but we were this time. How much of the excess reactant is left over? Let's look again. When it's asked for how much is left over, convert the product made to excess used. So let's start with that 6.93 grams, 0.693 grams of H2, and go to our excess, the Mg. If you've mastered grams to grams and the basic stoic, we're just doing that in different situations here. And I have all my numbers here to use. 2.02 grams of H2, we're in 1 mole of H2. According to the balanced equation, 1 mole of H2 is produced for every 1 mole of magnesium. And then 1 mole of magnesium is 24.31 grams of magnesium. All my units cancel. I'm going to take 0.693. I'm going to divide it by 2.02, multiply by 1, divide by 1, multiply by 24.31, and we get 8.34 grams of magnesium, but this is not the answer. This is always talking about how much was used to make that 0.693 grams. So the hydrochloric acid was limiting. That's all used up. The magnesium, we started with 25 grams of magnesium. We used 8.34 grams of magnesium. So I think we get about 16, and again, going to the 1 decimal place, because now we're subtracting, we get 16.7 grams of Mg would be left over. Okay, I hope this helped.